I used to think prompt engineering was just about writing better sentences, like be more specific or give more context, but after spending a week actually researching it, I realized two things. First, there are real name techniques people use that go way beyond write a better sentence. And second, some of the classic advice that you'll find online has quietly become less relevant, while one of the most powerful techniques barely gets talked about. Hello, if you're new here, my name is He. I make videos about web development and AI, mostly the practical and hands-on side of things. And for the past week, I've been researching prompt engineering, what it actually means, which techniques people talk about, and what the best practices really look like when you sit down and use AI every day. So this video is basically a summary of everything that I've learned. So let's start with the obvious question, what even is prompt engineering? So prompt engineering is the practice of designing input so AI gives more reliable and useful outputs. So think of it of less like talking nicely to AI and more like writing a clear brief to a contractor. The clearer the instructions, the better the output. And one of the most commonly referenced techniques is called short prompting. A shot is basically just an example that you provide inside the prompt itself, and these examples live entirely within the message. And there are three common approaches. First, zero-shot prompting. You give instructions but no examples. This works very well for simple or clear tasks. For example. Second, one-shot prompting. You provide one example to show the model the exact pattern that you want. For example. And then third, few-shot prompting. You provide multiple examples. This becomes really useful when the task is nuanced, contextual, or needs consistent formatting. For example, the model learns from your format from the example, much more reliable than just describing what you want. Another well-known technique is chain of thought prompting. And this idea is to encourage the model to reason through a problem step by step rather than jumping straight to an answer. And this tends to improve output quality on logic, planning, and problem-solving tasks. For example, without chain of thought. And for example, with chain of thought. The second version reliably produced more accurate answers on multi-step math and logic problems, even when the model could technically get there without the instructions. Now, you might have heard that this technique is outdated, and there's a nuance worth understanding here. So modern frontier models, like the latest version of Claude, ChatGPT, and Gemini, now have built-in extended thinking or reasoning modes that do chain of thought automatically. So if you're using one of those, you often don't need to explicitly prompt it. But if you're using a smaller and non-reasoning model, explicitly asking it to reason step by step can still make a meaningful difference. But here's the catch with chain of thought. Sometimes the reasoning path itself is wrong, and the model follows its logic confidently to the wrong answer. And that's where self-consistency comes in. Instead of relying on one reasoning path, the model explores multiple possible paths and picks the most consistent answer across them. And think of it like asking several people to solve the same problem independently and seeing which answer comes up most often. For example, and what the AI response might look like this. 2 out of 3 paths landed on $15, and that's the final answer. And that's the whole point of self-consistency. And this matters most for reasoning-heavy tasks, math, logic, and multi-step planning. Directional stimulus prompting, or DSP, sounds complicated, but the idea is pretty simple. You're steering the model's attention toward a specific part of a topic that you care about without completely controlling the answer. For example, and one of the most underrated techniques is just breaking work into smaller steps. Instead of one giant instruction, you sequence the work. For example, and this consistently gives better results than dumping everything into one prompt. And because you're reducing the complexity, the model has to juggle at once. Okay, so this is the one that barely gets talked about in the prompt engineering guide, but in practice, it might be the most impactful thing that you can do right now. Context windows are now massive. Modern frontiers models can handle hundreds of thousands or even millions of tokens at once. Instead of crafting a perfect prompt, you can often just paste in way more relevant context, the actual email, documents, or notes that you're working with, plus any background the model needs, and let it work with the real information. For example, a weak prompt looks like this. And another example, same ask but with context window leverage. The second version gives the model the actual emails and the actual context, no guessing required. In my experience, this consistently outperforms any amount of clever prompt wording. So before you spend time optimizing your prompt wording, ask, how I actually give the model enough context to work with? So after spending a week going through all of this, here's the thing that stuck with me most. Prompt engineering might still be important, but maybe not for the reasons people usually give. For me, the real value isn't the techniques themselves. It's that thinking carefully about how to prompt AI forces me to actually understand what I want before I ask for it. And that's a surprisingly rare thing. Most of the time, we go to AI with a vague idea and hopes it figures out the rest. But if you can't clearly describe what you want, the model can reliably give it to you. So in a weird way, prompt engineering is less about AI and more about clear thinking. The better you understand the problem, the better you prompt, and the better the output.